to build a circuit, we need to connect our conductors together. So we'll have something like a resistor and an LED, and we need the legs to touch so that current can flow through the LED, through the resistor to ground. One way we can make them touch is we could solder them together, or we could tightly wrap them around each other. But that's not very good for prototyping. In prototyping, we want to be able to build a circuit and then play with it and take it apart and move it around and change it. So that's where this device, the breadboard, comes in. So you have two breadboards in your kit. One is plugged into the Enscope board, and the Enscope actually just unplugs, so we can just yank that out if you want. And here's a regular old breadboard. Let's talk about how it's connected internally to figure out how do we make two wires touch inside of the breadboard. The breadboard is actually made of 3 pieces of plastic, and the middle piece has rows of wire, and the side pieces of plastic have columns. And each of these look like holes. And these holes are big enough for a 22 to 26 gauge piece of wire to slip inside. How do I know this is 3 pieces of plastic? Well, here's a breadboard that I've just kind of pulled open, and we can see that the side is definitely a different piece of plastic than the middle and another side. That means that electrically, of course, the side pieces can't be touching the middle piece. Now, the side piece we usually call rails. And the rails are typically used for power and ground connections. And so we have 2 sets of rails. And these rails are often given plus and minus signs. So we see on this breadboard it goes plus, minus, plus, minus. But that's not required to use plus and minus at those points. That's just a suggestion. So you might put plus 5 in ground and minus 5 or something into these rails. Now the middle part of the breadboard is where you do most of your construction. And it is organized into rows of holes. And underneath each row is a wire. So here's a wire under that row. Just like the rail is a column of wire. So there's one piece of wire there. That means that if we were to stick a wire into this hole, and we were to stick a wire into this hole, this wire is now touching this wire because of the wire that's inside of the breadboard. But if I were to stick a wire into this hole, this wire does not touch this wire because there's a break in the middle of the board. So the middle piece of the breadboard has 5 holes in a row, and then a break, and then another 5 holes in a row, 2 different wires. And then maybe I might stick a wire into this hole, which is in the same column as this wire, but this wire is not touching this wire because the rows are not connected in columns, they're connected in rows. Now, if you're curious about what's inside of the plastic that makes these fit together, there's a piece of sheet metal that's bent in some kind of hook shape, like this. And it goes in 3D like that. So that's what's inside of this row and inside of all these columns. So when you take a piece of wire from, uninsulated wire that you've removed the insulation from, and you stick it into this channel, this spring opens up to accept the wire and kind of pinches it inside of the breadboard. So if you want, you can actually take the breadboard, and most breadboards have double stick foam tape on the back. You could pull off the backing, so here's the sticky side, and you could pull off the sticky side if you wanted, and you could see all of the rows and the columns inside of this breadboard. That's just a sticky mess. But I've started to expose the back of some of those metal pieces. Cover that back up. You can also note that the rows and columns are given letters and numbers. It's not very typical, though, that we use those letters and numbers. We just figure out what holes we want to use. Now, if we're going to make some wires to touch inside of this breadboard, we want to remove enough insulation so that the wire fits snugly into a hole without leaving any exposed wire, because any exposed wire hanging out at that point might touch another row, which are pretty close together, and make a short. Some things use wires to plug in. Some things use stronger pins. So this is the backside of your end scope. So if you removed your end scope from your breadboard, you just pick any holes and stick it back in. Usually keep the top edge flush.